Hello everyone, welcome back to our channel. So we are starting with UVM series, and the first video will be regarding UVM Testbench block diagram and understanding how the block diagram works. So till now we know that there is a DOT, okay, and there is a TB. So TB applies stimulus to the DOT, correct? So in system Verilog, what we did, we provide stimulus to the DOT using system Verilog. But why the need of UVM came into picture? System Verilog requires a large number of files. So these large number of files at an industry level becomes complicated to apply stimulus. So what verification engineers did is they created a universal verification methodology. So what this does is, this is based on OOPS concepts and factory. This we'll discuss in future videos. So what this does is, this we created each and every component in this separately. So these are component based. So components and stimulus will be object. Okay. So one of the main thing of UVM is components and objects. Okay. So what this component does is, we create each and every component separately. Like we have driver component, monitor component, scoreboard component, and each has its specific tasks. So driver will drive the stimulus to the DOT, monitor will take the transactions from the DOT, and scoreboard will compare the input and output and expected and actual values with to the golden reference, and provides us like if the stimulus and RTL output is correct or not according to the stimulus we have provided. Correct? So up till now what we understood is, UVM contains component and objects. Okay, components are driver, monitor, scoreboard, sequencer, agent, environment. Okay, and objects will be sequence item. Okay, so this is the basic understanding that will be required to understand the block diagram. So let's start with the block diagram. How does it look like and how it works? Okay, so let's see. Let me select white pen. So let's create a whole top. So this is top.sv file. This is the base file which contains all the components. Okay, now inside this top, let's say this is DUT. Okay, and what it does is, it contains a whole test bench environment. We call it ENV. Okay, now we have to provide stimulus to the DUT, and we have studied in system Verilog that environment is a class which is dynamic in nature, and DUT is also here instantiated in top, but we know DUT is static in nature. Okay, we cannot directly combine static components to dynamic, right? So we require an interface between this. this we call it, let's change the color of it. This is an interface. Okay, let's call it interface. Now what we do is we have to provide stimulus to the DUT through the environment. Then we use interface and we collect the output from the DUT via interface also. Okay, hope it is clear up till now. Now let's see how each component inside will look like. Now we have studied like environment contains agent. This is agent and it contains a scoreboard. Okay, let's call it scoreboard. And this is agent. And agent will be basically a container class which contains monitor, driver and sequencer. Let's try lightset name monitor, driver and sequencer. Hope it is clear up till now. So this is the basic structure of our TB. Okay, now let's understand how it is getting connected. Now what we do is we drive the DUT via driver. Okay, whenever we want to apply something we use the driver. So we'll send the transaction to the interface via driver, and sometimes DUT will respond back with some response. Okay, so DUT will drive the interface values, say signal A, B, C. It will drive and get the response D. So this is what driver is. Now what monitor will do, monitor cannot drive the DUT. It will collect the transaction from the DUT. So interface will provide values. These will be the outputs of the DUT. Okay. Now monitor will collect the transactions or something from the DUT. It can never drive. Okay. This we need to understand. It will only collect the transaction. These transactions can be input value of the interface also, output values for the driver also. Basically, sorry, what I mean to say is this transaction can be the DUT's input also, DUT output also. Now monitor will collect the transaction and the transaction is getting collected into the scoreboard. Okay. Now scoreboard will calculate, or we can say it will compare the values if we provide and output is basically checked with actual versus expected. Versus expected. Okay. Now what happens? We will drive the interface and interface will basically apply the values to the DUT. DUT will react accordingly, provide the value to the monitor, will check if values are correct or not via scoreboard. Now we need to understand how these all are connected, right? Till now we have seen how the block diagram is. Now let's see how it is connected. Let me erase this. Okay, so the connection will work like this. Sequence and driver are connected via ports, in TLM ports. Okay, this we'll understand in future, like in future upcoming videos. What are TLM ports? We'll make a separate videos for this. Now, similarly, monitor is connected to the scoreboard via TLM ports. Okay, so this is the main connectivity diagram. Here we can understand it. You can take notes of it also. So this is the main diagram, how it works. Now, uh, now you'll ask, like, what do we drive? Okay, so we have driver sequencer handshake. This driver sequencer handshake is there. Okay, so what sequencer will does is, sequencer will provide something to the driver, right? It should give something to the driver to drive it on the duty. So those things are called sequence items. Okay, and those sequence items are getting called in a sequence. Okay, so sequence item in a sequence, which is called by sequencer, and all in all, this sequence item are drive to the interface through the DUT. So what we understood is, we have sequence item inside sequence, and for using sequencer, driver. So using sequencer driver handshake, we provide stimulus to the DUT. This is how it works. Okay, so sequence and sequencer, there is like a large number of, what based on the TB, what we can do is, there are multiple agents, as like, if duty is very big, we have multiple number of agents, we have multiple number of sequencers, we have multiple number of drivers. We'll understand all this, how the whole test bench will work, how the whole test bench will look like in future videos. So for this, like, you can see how UVM test bench looks like. So hope you understood this concept. Please let me know if you have any doubts.